Our next topic is data transfer between the caller of a procedure and the procedure itself, the callee. So in x86-64, up to 6 numbers or integral arguments can be passed to a procedure using registers, and these are just sort of arbitrarily picked registers that they decided to be used in this particular order. So RDI would be the first one, and then RSI, RDX, RCX, and so forth. If you have more than 6 arguments, or if your parameters are not integral, they don't fit inside of an integer, then you have to push them onto the stack. It's conventional that you push them in reverse order. The details of why that is the case aren't really important here. And then you have a single return value that is passed back via RAX. And again, this was just sort of arbitrarily chosen to be the return register. If you need a function to return a larger struct, this is often accomplished using a pointer. So the procedure, the callee, may also need some local storage, so it may need to be able to use some registers and some memory space. So some registers are designated callee saved. So in x86-64, it's these registers that are listed here. If you wish to use these registers inside of a procedure, you are supposed to save and restore these values. Usually you can do this simply by pushing the old value onto the stack and then popping it off at the end of the procedure. And so it's a good idea to kind of avoid these registers when you can, because that's a little bit of extra overhead for your procedure. All of the other all of the other registers except for RSP are caller saved, which means that the callee is free to use those registers and the caller needs to save them around the call site if they want them to be preserved. Of course, the stack pointer here is a special case because it is used for communication between the caller and the callee, so it's not really callee saved or caller saved. If a procedure needs space, one place it can allocate space is in the stack frame itself. So if it has something where you know how much space you need, it's convenient to be able to just store it on the stack so that you don't have to allocate space on the heap. And so local procedures are allowed to do this. You can just subtract the number of bytes that you need from RSP, and that reserves space on the stack for you to store things there and retrieve them. And you can just deallocate the space by restoring the old stack pointer value when you're done. If you don't know exactly how much space you need when you're programming the function, then you're going to have to introduce some mechanism for tracking the old location of the stack pointer before you adjust it. And it's common to use RBP, which stands for base pointer, as sort of an anchor for the current frame. And so if you have a variable number of bytes that you want to allocate inside of a function, then this is the most common mechanism for doing this. So this sets up something that's a little bit more complicated than we need to talk about here. I just wanted to give you a little taste of it because we'll cover this in more detail later on when you take CS430, and if you take 432 as your advanced systems elective. We'll be talking about this in quite a lot of detail, and I teach this courses, so I have this slide readily available. So the idea, once you kind of put all this together, is that you use the base pointer to track the beginning of the current frame. It's very nice because once you have everything set up, you can access all the parameters to the function using fixed positive offsets from the base pointer, and you can access all of your local variables using fixed negative offsets from the base pointer. And you'll just have these base pointers acting as sort of this chain up the stack. So that you can do a stack trace like GDB does. And so you just sort of push and pop RBP just like return addresses. And so there's this somewhat elaborate scheme for setting all of these things up around the call site and at the beginning and end of the callee. So again, these details aren't particularly important in this course, but I just wanted to give you a little bit more of an appreciation for the level of detail involved in making sure that procedure calls work robustly at the binary level.